Welcome back to the second part of our macroeconometric modeling and forecasting session. Now, this is a continuation of the first part, and in this particular session, we are going to look at how now we estimate the behavioral equations, the four behavioral equations we had. So we are going to look at how can we estimate them. So to estimate an equation, you go to this part written object, then you say create new object. Of course, it is a new equation. Then we are going to label it. We are going to start with the first equation, which is private consumption. So we are going to call this equation uh, a private consumption. Once you have that, you click OK. Then we write our equation now here. Remember, our equation was a function of uh, gross domestic product and a lagged variable of itself. So we are going to actually write it in log, form log CP, log CP C, then we have log PIB, then we have log uh, uh, lagged variable of itself, -1. That's how we write a lagged variable for 1 year. Then we are going, it should be least square. Remember, we are using time series, and we are using the ordinary least squares. Of course, the sample is from 1972 to 2002. Once you have that, this one should have another bracket. Then you click OK, and that's it. We have it. Now you can see our model now, our first equation, how it looks like. Now, there are important things. One important thing I would like to emphasize is the Durbin Watson statistic, this one over here. Now, the Durbin Watson statistic actually uh, measures correlation. It measures correlation, or what we call serial correlation, in residuals from regression analysis. Now, if you can recall from your econometrics studies, autocorrelation is actually similarity. We are looking at similarity uh, of time series over successive time intervals. Now, the disadvantage, or when your data has autocorrelation, it can lead to underestimation of standard errors, and this can cause you to think that your predictors are significant when they are not. So that is a very risky thing to have, autocorrelation. Now, normally what happens with the Durbin Watson test statistic, it gives you a report whereby it ranges, the values of the report ranges from 0 to 4, where 2 means a value of 2, for example, here could mean there is no correlation. A value of 0 to 2, it means there is positive correlation, and that one is very common with time series data. Now, a value whereby it ranges between 2 and above, 2 to around 4, that is above 2 to 4, then that is a negative autocorrelation, which is very less common in time series. So as a common rule of thumb, we usually say a range between 1.5 to 2.5 is relatively normal, and that is acceptable. For example, looking at our Durbin Watson here, it ranges between 1.5 to 2.5, which means we are okay with our equation. But values more than 1, that is more than 3 or less than 1, then there is a cause for concern. It raises alarm, and you really need to go back to your parameters and reconfigure them again. Having said that, now you know what the Durbin Watson statistic represents. Now, looking at our first equation, that's it. Let's now go to the second equation that we need to estimate, which is private investment. So again, we go to object, new object. Then of course you can see our equation, our private consumption equation is well labeled. So we are interested with private consumption. So we are going to say equation, then uh, private investment IP, then click OK. Then you define your equation. So again, we use log uh, IP, then we have a C, then we a constant that represent constant, then we have log. It was a function of gross domestic product, PIB. Then it's also a function of uncertainty, INC. Then you have lastly the lag variable of itself, which is IP -1. Then you have it. Then from there you can click OK. When you figure out everything is okay, then you click OK. Let's see the values. Look at our Durbin Watson statistic. It is 1.861. Look at the R squared, 91%. That means the variables explain our model 91.6%. Adjusted R squared 0.904. That's okay. And then that is our second equation. Let's go to our third equation, which is exports. Of course, you create new object, you label it here. We are going to have equation exports. Then you specify your equation. Of course, you have to put it in log terms. So it is log exports constant. Then you have log. It is a function of gross domestic product and is also a function of real effective exchange rate. That's it. Then ordinary least square. Then we click OK. That's what we have. Our R squared is 75.374%. Our adjusted R squared is 73.323%. Of course, you can look at our Durbin Watson here. It's 1.898. It falls within the range of 1.5 to 2.5 that we stated. So our equation again is okay. Of course, you can look at the coefficients here. In other words, you can look at the representation of the equation here. So this is what we have. The real representation, estimation of equation, the C, the coefficient, then you have log PIB, log C3. Of course, the coefficients are this one 1.21, 0.76, and -0. So all these correspond to what we have in our equation here. When we get back, they correspond to these values. Now, the other equation we have is imports. So let's create an equation for the imports. Object, new object, then you label your equation. Is equation imports. Then you have it. Then you specify your equation. It is for imports, log imports. I think this is the only part that you have to type the equations. So it's a function of gross domestic product PIB. Then it's also a function of real effective exchange rate and denoted as TSERF. That's it. And then click OK. Then you have the results of your equation. Of course, the Durbin Watson, it's 1.69. It's within the acceptable range. Then you have the coefficients here, and you can actually get a view of how your equation looks like in actually estimation or equation or in law in substituted coefficients. Now, once you have that, we have the four equations, our behavioral equations, we have them now. Let's look at them. So let's look at our behavioral equations. Here they are. So we have the first one for private consumption, we have the second one for private investment, we have the third one for exports, we have the fifth one for imports. Now we are going to use these four equations to create our model. But before we create our model, there's one thing you need to remember. There was this Excel spreadsheet that we were looking at, this one. I had told you that we had left some parts for prediction. That is 1998, 1999, all the way to 2002. Of course, they are blank for all the endogenous and exogenous variables. So, of interest to us, we cannot handle, or we cannot move forward with solving the model when all these are blank. Of course, if you go back to your parameters or variables here, if I open for example, the private consumption, you'll find it is still blank for those years that I was to estimate. So I showed you one way of actually predicting the equations, so that you can populate them to enable you solve the model. And one of the way we said, uh, was using a non winter Holter method for non-stationary equations, and for stationary parameters you are to use what we call simple exponential method. So for this case, I will repeat the process like I did in the first video, and I'm going to predict the years 1990 to 2002 using those said methods. So in the case of private consumption, it was a non-stationary variable. Therefore, I'm going to use uh, the non-Winters Holter method to estimate it. So let's go to quick, then series statistics, then exponential smoothing. Of course, our variable is private consumption. Then we are going to use Holt-Winters non-seasonal, and then of course the years is 1972 to 2002. Then to distinguish it from the other variable of private consumption, I'm going to say this is for prediction, predict. Then we have it, say okay. So if I go back to my window, I will find it labeled, yeah, just uh, below the real variable. I have it here. So we are going to do that for all these variables so that we can now be able to solve our model. So I'm gonna move fast, assuming you'll also do the same and get the same results as I have. So the next one is exports. So I'm going to exports, do the same exponential smoothing. Exports, they were non-stationary. Of course, we used the same strategy. So exports, uh, it's we have to label this as prediction, predict. Then we are using Holt Winters non-seasonal because it is non-stationary. And then we have the results. We go back to the window, and you can find it here. Here it is. Then we go to uh, public expenditure G, quick, series statistics, exponential smoothing. Series name is G. Then it was non-stationary, therefore we use non-seasonal Holt Winters. Then time back. Let me try to close some of this. So it should remain. So I need to rename it to show it's a prediction. So it was predict. That's it. Then again, we do the same for inputs. Quick series statistics, exponential smoothing. Then we have inputs, predict, defined. Oh, sorry for that. We should have gone to series statistics, exponential smoothing, inputs, then okay, and seasonal, yes. Then go back tile. Let me close some of this. Of course, here it is. Then I rename it. So we have predict. That's it. Then we go to the next item, which is uncertainty, quick series, exponential smoothing, INC, uncertainty. Then it was also not stationary, therefore we use Holt-Winters method, and there it is. Let's rename it. Rename science prediction, and there we have it. Then we have private investment as our next parameter. Series statistics, exponential smoothing, IP, okay. It was also not stationary, therefore we use Holt-Winters not seasonal, okay. Then we have it, let's see, and so you can see it's not difficult task to do. It's very simple as long as you understand what you are doing. So this one is a predict, it's a prediction. So of course now you have it there. Then again we are going to do the same for our gross domestic product denoted as PIB. So again, quick series statistics, exponential smoothing. Then we have PIB. Okay, again it was non-stationary, therefore we use Holt-Winters now seasonal. Then again, okay. Make sure you have it well labeled. So I'm gonna label it as PIB prediction. There we have it. Lastly, we also have real exchange rate. We also have uh, to populate it. So again, do due diligence. Again, it was not stationary. We use Holt-Winters and more seasonal. Then there we have it. Make sure you have it labeled correctly to avoid confusion. And of course, here it is. Then I rename it. I rename it the red suffix. Then lastly, we have so let's deal with change in inventories as our last variable. If you can recall, our change in inventory was the only variable that was stationary, and the only way to predict a stationary variable is through what we call uh, a simple exponential smoothing. So for this one, we are going to use simple exponential smoothing and not Holt-Winters no seasonal method. So we are going to estimate these using simple exponential smoothing, and here it is, simple exponential smoothing. Then our series is a change in inventory. Of course, we are going to use the smoothing method now, simple exponential smoothing, the single one. Then okay, are going to look at how it has been saved from our file, and of course here it is. So let us rename it to reflect our change. It's a prediction for the next 5 years. Now, once we have all the predictions for the 5 years, now we are going to do one more thing, and that is making sure now we open them as a group, and then we populate our original data with the predicted values, so that when it comes to running the model, those values are not blank. Otherwise, if they are blank, the model will not, EViews will not run the model. You will end up with an error somewhere, and that will impede your results. You cannot get results. So that's why we are doing all this process, or that's why we are undergoing all this process. So what we need to do, we now need to populate these predicted values to our original data, which did have them from 98 to 2002. And the reason for doing that is to enable our model, uh, to enable the EViews to run our model. So of course we are going to copy from 1998 all the way to 2002. Copy, then of course it will be displayed as a text. Then here you say paste. That's it. Then you move to the next one. Let's move to the next one. The next one is exports. Open them as a group. Then again copy the predicted value to the original data. So we are populating the original data with the predicted values. So 1998 all the way to 2002. Of course you copy the data, then you paste it, Control V. Of course, yes, Control V, that's how we do it. Then you have your original data now populated. Then you move to the next one, which is, let me close this. Then let's move to our public expenditure, sorry, is our next item. Open them as a group, then populate them, copy the data. This is what we need. 1997 all the way. You copy, okay, then you paste, Control V. That's it. Then do tile. Then we move to the next one, which is imports. We are looking at the imports. Then we open as a group. Then again we do the same thing. You copy the original. You copy the predicted values. Copy, then okay, then paste. Yes. Then move again. Uncertainty, then we have to deal with that again. Open them as a group. Once you open them as a group, again we do the same. Copy them to the next, the original data, and then go to the tile part so that we can have our original screen. Then we have private investment. Do the same. Open them as a group. Uh, Copy the data. That's it. Copy. Then you paste. That's it. Then go back to original window. Then we do the same for gross domestic product. Do the same. Copy the data. There it is. So you have to be patient a bit. It takes time, but it's easy. It's not a tough thing to do. Once you have that, then go back to your original window. Then we do the same for real effective exchange rate. Yeah, it is a real effective exchange rate. Copy, then you paste. There we have our data. Go back to original window through tile. Then lastly, we have the change in inventory. Open as a group. Then do the same from 98 all the way to 202. Then Control V is our shortcut. Then we have it. So let's now, I think I've populated every variable, both endogenous and exogenous. Now, once you have done that, now it means now we can solve our model. So remember, the purpose of this of doing everything is to enable estimation of our model. You cannot estimate your model with missing values. That's why we do the prediction for those years. And we do that by populating both the endogenous and the exogenous variables. Now, once you have that, you go back to your original equations. They were for the behavioral equations. Then you open them as a model because we really want to solve now the model. Now, remember we had an identity equation or the resource use balance equation. So we need to put that equation as our identity, as our accounting equation. So just left click on anywhere on this white part, then you say insert. So our equation was, it's generally a GDP equation. PIB, which is gross domestic product, is equals to uh, private consumption plus private investment plus government expenditure or public expenditure, sorry, plus change in inventories plus exports uh, minus minus the imports. That is our GDP. Basically, that's how we even calculate GDP. Expenditure, or yeah, it's expenditure using the expenditure method. So once you have that, it's our identity equation. You click OK. So we have it now. So once you have now all the 5 equations, you can now solve the model. Just click solve, then you decide. Now for this case, we are going to use the deterministic simulation type and a dynamic solution. You can also have the other stochastic statistic. I'll be covering a video on in detail about stochastic and static solution. But for now, we are going to deal with deterministic and dynamic solution. Of course, the solution sample, that one you can leave it blank. Uh, but if you wanted to work on a shorter sample, you can just specify it there. So with that, once you are certain everything is okay, if your model does not have any issues, if your equations were perfect, then the model will run perfectly. Of course, very fast. You have the model now. You can see here we have a solve, and the solve complete. It's now complete. So we don't have any issues with our model. You go back to your original window, then we want to see now our model. So the values denoted as 0, you can see we have export 0, import 0, IP 0, PIB 0. In other words, it's our baseline solution. Those are baseline solutions. So we are going to open our baseline uh, solutions and see. No. Now remember, there's something we need to distinguish. Of course, we had populated our data here to enable us run the model, the original data. So we need to remove now that data. We need to remove it, edit, so that we can now see how our model has functioned. It was from 1998 to 2002. Of course, we can remove the data so that now we can see how our model looks like. That's it. Then let's go back to our original private consumption. Let's see how private consumption our model has solved that. What do we need to do? We need to go to tile, arrange. We need to go back to this. No, no. Where is the file? Where is the file? Yeah, there it is. So we really need to see now what has happened here. So let's compare our baseline solution with our original data and see what we can have. So open them as a group, then visualize that. Let's visualize this. Of course, now we want to see for those 3 years, for 5 years, how our data looks like. So you see, you go to the graph part, want to see them as a graph, then we click OK. Wow, you can look at it now. You can also see how the model fared, the baseline model fared on. Of course, you can see the prediction not too bad. It was not too bad at predicting. Of course, there are minimal variations. You won't get accurate prediction results unless it's luck, it's pure luck. But this by itself tells us that actually the model is good in predicting our results based on the differences or the variation from the original data. Let's go to the second one, tile. Let's look at private investment. Where is it? Here, the baseline solution and the original data. Let's look at how good it was at predicting. There it is. We need to view this as a graph. There it is. Look at how the baseline did a good job at predicting our original data. So that tells us our model will not be worse off when it comes to prediction. When it comes to predicting or when it comes to forecasting future results, because you can see the variation. It's not that there's no huge disparity in the results that are being displayed. Let's look at that is private investment. Let's look at our exports. export. How have they as a group? We need to see it in graph. Those are the results. Aha. Even the baseline, again, it's not worse off when it comes to explaining or when it comes to predicting the results. Of course, you can see their variations, but generally it has done a good job. It can predict our future with a with a little margin errors. Aha, let's look at our inputs. Let's see how well our model can predict our inputs. Inputs, the baseline, the original data, open as a group, uh, then view as a graph. There it is. Aha, look again at the inputs. Again, you can see not a bad job done by our model. Let's go to uh, what our GDP. Let's see how well the model can predict our GDP as a group. There it is. View. Then we want to see it in form of graph. Again, you can see. I think for the GDP, the model could have done a good job. The prediction, you can see it moves at par with the original data. It didn't do a bad job in predicting, so it can do a very good job in predicting our values when it comes to GDP. Finally, let's look at change in inventory. Change in inventory, it is open as a group. Uh, let's see how well it can predict our values. There we have it. Of course, yeah, again, not that bad. The only places where maybe it did bad is maybe here is a huge disparity, and also here we had this spike. I don't think it did. Let me see. I think I opened prediction instead of baseline. Oh yes, I did. So with that, now you have seen how well our model fares off. So that is the purpose now of modeling. You can predict values in future based on you can look at the past trend. How is the model faring on in predicting those values, and how well it can predict them in future. So you can see our model will do a good job in predicting our values for the future. So that marks the end of session 2. So we are going again back to session 3 now, whereby we are going to look at two least square. This was about uh, so this was all about ordinary least squares, and we were using what we call the time series data. Now next time we are now going to look at two least squares or double square, whereby now we are going to see how again we repeat the whole process to see what difference can we get in results using two least square instead of ordinary least square method. Then, of course, the last part, which will be part 4, will be looking at how now we do policy simulation. An increase of 10%, how will that affect maybe in tax? How will it affect our forecast? Maybe a devaluation of the currency, how will it affect our forecasts in future? And with that, now we can come up with a policy uh, that will aid in the respect to those results. Thank you for watching, and kindly subscribe as I make more of these videos. Have a good evening.